So on pages 18, 19, and 20 in your packet, we're going to focus on the properties of logarithms. And the properties of logarithms are going to remind you of a lot of the properties of exponents. We have the property that if you have x squared times x cubed, then you add those exponents and you get x to the fifth. Okay? So when you're multiplying the powers, you end up adding the exponents. Well, we have kind of a parallel property of that with logarithms. If you are taking the log of a product, you can split it up as a sum, log base b of m plus log base b of n. And so, for example, on number 1, if we're condensing, see problems 1, 2, and 3, you're condensing, whereas 4, 5, and 6, you're expanding. So condensing into a single logarithm, they have to have the same base to do this. And so since these are both base 2, then you can write this as log base 2 of 28. With these being both base 10, we can use the property. So this would be log 100, just multiplying 25 times 4. Here, log of 2x times 4x squared would be log base 4 of 8x cubed. That's log base 4 of 8x cubed, multiplying together the 2x and the 4x squared. Now, expanding, you have different options here, depending on how you choose to think of, for example, 6. If you think of it as 2 times 3, then you could rewrite this as log 2 plus log 3. Okay? Or here, if you think of 45 as, say, 9 times 5, then you could write this as log base 7 of 9 plus log base 7 of 5. Now, with this one, we would write this as log base 2 of 5 plus log base 2 of x. There's only one way to expand that one. Okay, the quotient property. So if you remember, when you are dividing exponents, so let's say we have x to the fifth over x squared, then you subtract, right? And we get x cubed. So when you're dividing powers, you subtract the exponents. Similar rule here. If we're taking the log of a quotient, then we can rewrite that. We can expand that as a subtraction of logs, a difference of logs. Log base b of m minus log base b of n. And so condensing in these cases is going to mean that we're going to divide whatever's the log, whatever you're taking the log of. And that number is called the argument, by the way. The number that comes after the base, whatever you're taking the log of, log base 3 of 24, that's the argument of that log. 8 is the argument of that log. So we're going to divide them. So this would be log base 3 of 3, because 24 divided by 8. And we'll just leave it like that because the directions were to just condense into a single logarithm, but technically this is equal to 1. This one, log base 2 of 15 over 15, so that one would be log base 2 of 1. Here, log base 4, this is x to the 9th over x squared, so that would be log base 4 of x to the 7th. Okay, and then expanding, again, answers may vary here. If you choose to think about 4 as, say, 16 over 4, then you could write this as log base 8 of 16 minus log base 8 of 4. Here, we write this as log base 5 of 1 minus log base 5 of 3. And then with this one, log m minus log 7. And the power property. So when you have a power to a power with our exponents, if we had x to the 5th squared, that was x to the 10th. So when you had a power to a power, you multiply the exponents. That's sort of what happens here. Because remember I told you that a logarithm is an exponent. So like that part represents an exponent, the log base b of m. So if that's an exponent raised to another exponent, this little n, what you actually get to do is bring this down to the front, bring that power down to the front, and this is equal to n times log base b of m. So essentially you are multiplying the exponents, because this is its own exponent. Log base b of m represents an exponent, and then this is the exponent on the exponent. The n is the exponent on this exponent, and then we end up multiplying them together. So condensing, we're going to bring this back as a power of the argument. So this would be log base 4 of 2 to the 5th, which is 32. Here, log base 2 of x to the 7th. Log 8 to the 3rd, remember this is base 10, and 8 to the 3rd is the same as the cube root of 8, so you could also write it like that. And then expanding, we're going to bring the power down to the front, so 7 log base 2 of 8. Here we're going to bring the x minus 1 down to the front, so it's going to be multiplied with the 3. So then it would end up being this. And those parentheses are important because you're bringing the entire power down. If you didn't have the parentheses, it would look like only the minus 1 was being multiplied by the log. But this whole thing needs to get multiplied by your log. And then here, think of this as log 7 w to the 1/2, and then bring that 1/2 down to the front. Okay.